Good afternoon, everyone. If you're joining us on the East Coast, my name is Whitney Stoll, your DC Post First Vice President. Alongside me is Bree Bill, our Programs Director, who is hosting our webinar today, and she will be monitoring our chat. So thank you all for joining us on our new platform. We have nearly 100 registered participants from all over the country. So I know you're excited about this program as much as we are today. It is my pleasure to welcome you all to our September First Friday luncheon session. And please join me in welcoming Christopher Fillmore from IMEG, who are presenting Exploring New Applications in 3D Laser Scanning, Enhancing Design and Construction throughout the AEC industry. So we'll be looking into the evolution of 3D laser scanning and how you can apply this technology to ignite creativity and innovation to your own projects. But first, I'd like to start our welcome by introducing you to our First Friday series, which is provided to you through SAME's commitment to offering the AEC community effective training, development, and networking programs. The DC Post is helping sustain the future of this profession with these monthly education-focused sessions to deliver topical and relevant content to our industry. So thank you all who are joining us here today. So please feel free to use the chat to introduce yourselves to everyone throughout the presentation, ask questions so we can address them during the Q&A, where you're calling in from, your company, any LinkedIn or contact information. Also, this is a lunchtime session for those joining us on the East Coast, so feel free to eat your lunch during the program. So we are glad you could join us here today, and we're happy that we could offer this virtual program to our community, regardless of where you're attending from. Let's start with a moment of silence to remember our active duty military, first responders, and all who need our care and thoughts throughout the world right now. Thank you. And please join us in the Pledge of Allegiance. So I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thank you. We'd like to take a moment to thank all of our DC Post sponsors for your support: AMT, Black & Veatch, Christopher Consultants, Consigli, Gannett Fleming, Spinny Yellow, Stantec, WSP, Jacobs with Peacock, AB Facility Service Solutions, Arche Consulting, Prime AE, and Stanley Consultants. So we truly appreciate your support. We could not have put on these events without you, and we are grateful for your outstanding sponsorship. So your support helps us meet our society's strategic goals, including providing excellent content for our members, industry and government engagement, building resilient communities, connecting with our future leaders through student and young member groups, enriching the STEM pipeline, and preparing our military and veterans for life after service. If you're not already a DC Post sponsor and would like to support our post with annual sponsorship, we'd love to add your name to a list for future programs and events this year. So please visit our website for more information on sponsorship levels and how you can give back to your community through an annual post sponsorship. And now it's time for the main program. So this program will provide a professional development hour from the DC Post. Look for an email with the subject line document delivery from SAME DC and Eventbrite with the copy of our program slides, your PDH certificate, and an opt-in attendees list for those who pre-registered for the session. We are recording this webinar and we'll post the video on our website later on. I'm not going to read the learning objectives for the slides since most of you saw these objectives when you registered. So now I'm going to introduce our featured presenter. And if you haven't done so already, please feel free to use the chat, introduce yourselves, share any contact information, as well as use the chat throughout the presentation. If you have any comments or like to ask any questions for our presenter. And towards the end of the event, we'll have a Q&A session for Christopher. So now to introduce Chris. So Chris Fillmore is a licensed land surveyor in Virginia and DC with over 28 years of professional land surveying experience. He is a client executive with IMEG, where he has been leading and is responsible for the strategic growth of survey and subsurface utility engineering teams operating up and down the East Coast for the past 18 years in commercial, federal, and military-based projects. So Chris is a graduate of Old Dominion University in Norfolk and is an expert in 3D scanning and drone technologies as the technology has evolved into state-of-art innovation for today. So Chris, thank you for joining us here today, and I'm going to turn this over to you, and it's all yours.
Thank you for the opportunity to present on 3D scanning and the impact that this technology has had and continues to have on design and construction applications. Just like any technology over time, as the technology evolves from a specific application and becomes more mainstream for commercial uses, and as such, the price point of these devices continues to become more reasonable. The disruption in how work is performed continues to evolve for the better. The focus of today's presentation is really going to look at these three learning objectives. There's so much we can talk about with land surveying technologies, applications, and how 3D scanning has disrupted and reinvented how the land surveyor acquires data. We will talk about different case studies and look at what I believe is going to be a 100,000-foot view of 3D scanning. An aspect and something to consider with this presentation is the end uses of capture technology, and also what the land surveying community and other technologies can help are really boundless. A little bit about me. As Whitney said, I'm a licensed surveyor and I've spent the majority of my career in Northern Virginia working for IMEG Consultants. In this time, I've been able to work, manage, and lead on a lot of diverse projects that have required the use of bringing new technologies to figure out a solution for my clients. I've worked with 3D scanning since 2010, with my first introduction to it was in the city of Fredericksburg, working for the University of Mary Washington. At the time, they were developing an enclosed bridge to span the east and west sides of Route 1 corridor between the existing university and their new housing development. We utilized the 3D scanner to scan the constructed conditions of the bridge support structures before the bridge was lifted into place. And we also used the 3D scanner to confirm the placement of the bridge afterwards to ensure that the bridge fit within aerial easements that were worked extensively between VDOT and Mary Washington. A quick snapshot just on IMEG in general. We are a national engineering firm with offices in more than 80 locations. We handle a wide range of engineering and building solutions. My responsibility is surveying, but it is amazing how technologies like surveying are applied to all the various engineering fields that we're providing services on, from structural design and providing 3D scanning of existing interior spaces to MEP mapping and mechanical rooms and piping, all the way down to security design and lighting. There's not a department or an engineering team that can't utilize our 3D scanning technologies. To assist with the teams that do ask for 3D scanning, my team is located in Northern Virginia and the surrounding region. We operate up and down the East Coast and primarily work in areas where we're licensed. One thing about today's presentation is that we may talk about 3D scanning applications, but those are not the only 3D scanning applications out there. 3D scanning has become a tool that is used with other surveying equipment. So there's not just one tool to get the job done. So now as we start completing projects, we're keeping in mind, first, we want to make sure that our staff are safe. Two, we want to make sure that we're using the tool or group of tools that are going to efficiently acquire the data we need. And three, what is the most practical tool to get what we need the first time so we don't have to return to the site where we potentially will never be able to return to the site. Ultimately, the answer is that there's not just going to be one tool to complete an entire project, but the great thing is that all of our tools work together. This was not always the case, and I put this slide in here to remind us that how far surveying has come in a relatively short amount of time. In years past, our tools were very limited. As I mentioned, technology advances in society and military applications, and those transitioning from a specific purpose to be used more widely across multiple fields has really excelled our industry. These are just a few pictures of tools and also something to focus in on within these photos. If you look closely, you'll see it. Look at how many people it takes to operate a survey crew. Something that's going to be very important as we continue to move forward and we look at our 3D scanning tools and applications. But before we do that, let's take a look at how far our survey technologies have come. I talk about this because there's been a misconception about what we can do and what is available currently. Time-tested equipment and practices still govern everything a land surveyor does. The core principles of surveying are the same, whether it was in the 1700s or today. The mathematics are the same, or at least the core mathematics are the same. With the processing power of the computer, we've seen great advancements in technologies from the 1970s to the current, really changing how the tools and the processes to get the work done. I showed you the slide previously that showed the survey team and equipment look prior to the technology revolution starting in the 1970s for surveying. Let's take a moment and look at today's surveyor. From GPS to scanning to remote operated boats, all new technologies utilizing the core surveying fundamentals with the goal of finding the position of an object on the Earth's surface. Today, one person can do the job of many, and in the near future, robotic tools such as Boston Dynamics Spot with carrying payloads like 3D scanners are really going to continue to revolutionize how and where we go with this. I do wonder what we will be doing and or where we'll be going with these technologies in the future. So all of these tools are great and continue to get more advanced. But when I say advanced, the internal parts of what they can do become more advanced, while the acquisition or how somebody goes out and collects the information is coming down to pressing a button and waiting. Manufacturers make it very easy to acquire the data, but we all need to understand that the regulations and project specifications govern how the technology is applied, and the experienced professional need to ensure that the answer that is given is correct. Because a vendor says their equipment can get better accuracies than anyone else's equipment, they usually leave out the fine print of what outside resources are needed to get to those accuracies. Ultimately, I want to stress, though, to everybody that the land surveyor is equipped with many different tools. There isn't just one thing that is going to acquire all the data we need on the project. Things like safety, site conditions, and efficiency are all going to dictate the workflow from the time that you arrive to the site to doing the work to the time that you leave the site and acquire all the information. For the tools, we need to understand that these technologies do cost a sizable amount of capital, but when we have a diverse range of tools, we can start thinking not just about the information you have acquired today, but what else could you possibly use the data, because you're going to get gigs to terabytes worth of information. And information is impactful in today's society and in all of our engineering applications. Let's talk about these tools in our toolbox and how we measure physical improvements. And this will lead us to reasons why 3D scanning has become so impactful, and I said earlier, really disrupting how surveyors survey. First, we're going to start with the tape measure. It's our most basic tool. It's easy and able to acquire distances to small objects, but it's not practical to figure out where an object is in the world, and trying to measure a big object is going to take a lot of time. A tape measure also assumes that the surfaces are plumb or square without additional information. Imagine, look around your space currently. If you're sitting in an office and you're in a large office space, imagine how long it would take to measure all the walls, measure all the outlets with a tape measure. Next is our total station. It is a telescope that has technology to measure an angle and emits a laser to find a precise distance. This is our surveyor's main tool in the toolbox. The concept has been around for centuries. With technology advances, has become very accurate in measuring a precise angle and measure a precise distance from a reference point. This is the line of sight technology. When I say line of sight, because I am going to talk about a couple of different challenges with equipment. So when I say line of sight, that is meaning what you see from looking through the telescope is what you get. If you can see it, you get it, in the sense that you can measure an angle and a distance to find its position. If you can't see it, then there are other tools, but for the total station, unless you see it from a different vantage point, you won't be able to use the total station to collect and observe that information for future use. The early 1990s brought GPS into the mainstream, and most surveyors have GPS capabilities today. Measuring objects without the need for line of sight is great, but we have another challenge with GPS, sky view. We need to actually be able to see the satellites in the sky as they cross the horizon and through the sky where we're working in order for GPS to work appropriately and provide the accuracies that are needed to be survey accurate. But, really we're here today to talk about the age of 3D scanning. Unlike its predecessors, where we discussed shortly ago that, all those tools measure to a single point. And so if we go back a stage, your GPS is collecting to one point at a time. A total station is measuring to 1 point at a time. A 3D scanner, though, is going to take many observations at a very dense grid over a specific distance. That means that in a very short time, depending on how far away the scanner is from the object, a dense grid of X, Y, Z coordinates, or really real-world coordinates, can be obtained. These devices and measurements do require line of sight, so we have to have the instrument laser that comes out of the scanner. It actually has to hit the object and reflect back to get measured. It will not be able to see through walls. Like other tools, a static scanner tool will sit on a tripod. It's stationary and it does not move while capturing the data. Mobile scanner, similar to the static scanner, is a tool that uses the same laser technology to create point positions. While the static scanner occupies a point in space and scans what it sees, using very new technology called simultaneous localization and mapping, or SLAM for short, the mobile scanner doesn't have to stay still and can actually acquire data while moving. Attaching this to a vehicle or even to yourself as you're walking in a backpack form lets you map and localize yourself and create a map in real time. UAV or drone applications. Similar to the mobile scanner, the UAV is going to be any unmanned aerial vehicle that has a LiDAR or 3D sensor payload that acquires 3D data. While what we talked about before are technologies that collect data within 30 to 300 feet horizontally on the ground, the UAV will fly a path somewhere between 200 to 400 feet above the object that, just like this static scanner, uses 3D scanning technologies to acquire the positions on the Earth's surface. The next few slides, we're going to take a look at the tools we use and why we use them. Also, when we use them and workflows that the surveyor considers, it needs to be understood that all of these tools are able to collect XYZ coordinates in some fashion, so we can actually use all of these various tools together to create, analyze, and prepare the required mapping. So we talked very generally about the total station. Now we're going to talk a little bit more about the advantages and disadvantages of this tool. As we discussed, it is one of the oldest and more reliable tools. It is a time-tested piece of equipment that's in the surveyor's toolbox. Remember, this tool measures a precise angle and distance. If I had been told during geometry class back in, I think it was 6th grade, just like I told my son recently, that geometry governs everything a surveyor does, I might have paid a bit more attention in class. It's true though, surveying is the function of creating a position on a grid or the Earth's surface, and its total station does this by creating triangles by observing an angle and a distance off of two known coordinates. There are a lot of advantages of using a total station. A total station, you can operate and see things at a very long distance. Purchase price is very affordable to most companies and surveyors, and it is a practical tool for everyday jobs. The disadvantages is that each observation creates only 1 point at a time. So it takes a lot of time to measure a lot of information that's on the site. A lot of the positions also collected do require our staff to hold a pole over the point. So as we're acquiring data, we may be potentially putting our staff in hazardous conditions, which we want to try to avoid at all costs. GPS is a tool that the modern era has developed for military applications, but it's been released for commercial uses since really practical in the 1990s. And the price has been driven down over the years to make it a tool in most surveyors' trucks. In the coming years, with the GPS framework being developed, the accuracy of the GPS sensors will also continue to get better and better to the point where we will, as professionals, be required to understand the velocity of tectonic plates in adjusting our point positions. GPS, like the total station, creates a single point, doesn't require line of sight, so getting out of the truck and just starting working anywhere is a fundamental advantage. The GPS accuracy does require the availability of the sky, so not being under tree canopies or in buildings, so we do need to be outside for GPS to work. There are other variables that affect GPS, but if the project is outside over a long distance, GPS is the best solution for the job. So with all the typical tools we consider, now let's deep dive into 3D scanning. The scanner, as mentioned, or rather I should say, a typical 3D scanner emits lasers over a grid of space at a certain distance. This means that a laser pulse is coming out of the instrument many times a second, and the instrument rotates 360 degrees on its axis. It then spreads out the laser basically between the 30-degree vertically on the ground to the same 30-degree on the other side. So we're creating a full 360-degree horizontally and about 270 degrees vertically. The scanner is line of sight, and the density of the point spread over the surface is really determined by the distance away from the object. So what that means really is, as the object is closer to the scanner, it will be scanned at a denser pattern than that several hundred feet away. Most practical applications, we like to see the scanner between 50 to no more than 400 feet away. And most of the time, the manufacturer will tell us the point accuracy at a certain distance. This lets us know how close we have to be to the object being surveyed to make sure we can achieve the accuracy required for that object. Cost is still a factor with static scanners, those that sit on tripods, but I must admit they have really decreased significantly over the past 5 years. With more inventory available and parts for the scanner and just how fast technology is becoming available, price points for scanners start around $20,000. You do get what you pay for, so the bells and whistles, the additional options on the upper end, we can still see those top tier scanners upwards of $90,000 to $100,000. One thing to keep in mind with any tool that collects point cloud data, or really to say the cluster of point positions coming from those reflected lasers back to the instrument, these files are huge. Like I said earlier, they're gigs to terabytes wide, big depending on the size of the project. To model these type of data sets does take the time and processing power. I found many years ago that the scanner does take basically half the time that it would take a normal field crew. So we can say that the scanner takes the field out of the field, but the processing time to take all that data will take longer than taking your traditional total station information or your GPS information and modeling it. Mobile scanners are very similar. They get point positions more accurate and are becoming even more comparable to static scanners with each iteration of the equipment. Still on the expensive side, it is amazing the ability to walk around a space and the amount of data that is collected in such a short amount of time. When I say mobile, if I have not done a good job explaining this so far, let's take a look at our static scanner. A static scanner is where you put a scanner on a tripod and click a button and it spins a full 360 degrees. This can take anywhere from 2 to 5 minutes to acquire information from one position. Once you're done, you're going to move the tripod to a different spot and do the same thing over and over again. So each spot that the scanner and the tripod are sitting can take anywhere from 2 to 5 minutes. Mobile scanning, we just walk or drive at a certain speed and collect the data. In the walking scenario, which I have a little bit more experience with, as you can tell from the image on this page, it is amazing the amount of data collected just by walking through the space. Like all 3D scanners, line of sight is key. I continue to stress this because this technology doesn't see around corners or through walls. So anything blocking the view, we have to consider how are we going to get to the other side to be able to see it. Does that mean that we're going to scan from a different position or a spot where we set the scanner and walk to? Or do we have to use a completely different technology in order to get it because the scanner just isn't going to get there? Before I change slides, I want to go back to the office space that you're sitting in right now and imagining measuring all of the walls and all of the outlets with a tape measure. That can take anywhere from 6 to 8 hours. Imagine how long it takes to walk through the space to get from one side to the other. That's about the amount of time that will be required today to scan your entire office space. Drone technology and drone scanning is great outside, and we're now even seeing drone applications and scanning enclosed spaces, such as tunnels, manholes, and others. Like its counterparts, the scanner is housed in a sensor as payload to the UAV. Depending on the weight of the payload will determine how big of a UAV you need to use. These tools are great because they are autonomous, where we can set a flight path to create a dense grid of point cloud data from the air and press a few buttons and wait. I say it's simple, but really, if my section 107 pilots actually heard me say that, they would say differently. These tools do require an FAA Section 107 pilot, and while it's simple to make the UAV fly a path, it's not as simple to handle the UAV if something goes wrong. At any given time, our pilots are monitoring the UAV performance and ready to take over if something does go wrong. For an object, if we take a look at how the data is acquired, we need to not think of things horizontally, but vertically. 400 feet away from an object is far for a 3D scanner. On-ground scanners have a sweet spot for most scanners. Each brand is slightly different, but in general, we like to be between 90 and 120 feet away from the object that we're scanning. On the ground, this is a full 360 degree from the instrument, so we are collecting a lot of information. In the air, typically our 3D scanning is looking straight down. So our sensor is looking straight down at whatever altitude that we put it at. So the amount of information it's collecting is actually less. So that's why we run flight plans and we do multiple flight lines in order to collect the same amount of data. We are typically flying the UAV around 250 to 300 feet for the most, for most land development survey applications. As the UAV does take GPS to fly autonomously, for those applications, GPS sky view considerations are important. So here are a couple of different types of scanners that we have at IMEG. There's a whole lot more on the market, and really just want to touch base with looking at what the spec is for each of them, so you do see that not all scanners are the same. So in the top left, we have a Matterport Pro 3. It generally can scan up to around 300 feet, but the accuracies are about 20 millimeters at 10 meters. So that means that at 10 meters or about 33 feet, the accuracy at that distance is going to be about 20 millimeters. RTC 360, which is the middle one here, can scan up to about 130 meters, and we can get accuracies up to 1 millimeter at this. The acquisition time, so for the RTC 360, we can scan about 2 million points per second compared to the Matterport, which is 100. I'm not going to go through each one, but as you can see, at different distances, the equipment can run different accuracies and also just the amount of points it can collect. Now, everything that we've talked about, this equipment are all tools within our toolbox. One thing to know is that all of these tools create real world points that we use together. They all measure points to different degrees of accuracy, and accuracy is important. The equipment, just like cars, have different models, functions, and something we will focus on is acquisition times. Time is money, and it matters. So the equipment we use and when we use it, we really look at how long it takes. 3D scanning saves a lot of time. We look at the amount of data captured. 3D scanning captures a lot of data usable now, but also look at the potential future use of it as well. Think of the amount of information that is captured and really think, well, you're focusing on one design iteration today and you collect that information. But then the second design iteration says, well, I need to go outside what I told the surveyor to get the first time. Well, with 3D scanning, we would have likely have captured that. We look at safety when we talk about collecting information. 3D scanning can acquire large amounts of data outside of hazardous work areas, making it a key tool. However, each tool does have disadvantages, so we really can never say that one tool does it all. Out of those listed, really the accuracy requirements is fundamental, what we surveyors consider. Remember, when we collect millions of points with a scanner, but each point has its own inaccuracy. So if the scanner specifications state it will take 2 million points per second, but each point is plus or minus 3 centimeters, no matter what you do, your accuracy at a single point is going to be 3 centimeters. Don't worry though, 2 million points at 3 centimeters, we have the processing software that will help average out and get good representation through redundancy of the average location. While never more accurate, we get a great model that will open how data is consumed differently than 15 years ago, or with survey applications that don't apply 3D scanners. What has been traditionally done, like interior measurements with tape, can now be done with 3D scanners just by walking through the space. What parts of a facility have to be shut down or completed on downtimes can now be mapped without shutting the mechanical equipment down, without closing roadways down, or stopping airplanes from taking off or landing. Taking measurements where the vantage points to get the measurement wasn't possible, and ultimately creating 3D models of real world with survey grade accuracy has brought 3D scanning into the mainstream. So let's move now from a 100,000 foot view to a 50,000 foot view with looking at scanning. And now let's deep dive into it, starting with a few pictures. So in the top left, you can see we have an aerial UAV scan of an existing building and surrounding space. All of this data can be mapped into real world coordinates, measurements derived, contours and relief computed. Historic monumentation, we can scan from a vantage point outside of the structure and provide real world information. Historic buildings, we're able to detail all of the high level of architectural features, moldings, trim to a degree that can be provided to an architect or an engineer for development of future plans and or how to renovate. We worked on one project where we had to catalog each brick in a exterior face of a building with the scanner to be able to put back those bricks afterwards. We've got active construction sites where we don't have to set foot in. The 3D scanner can capture all of this information accurately. And while this looks like a pretty picture, every pixel in here has a real world coordinate that information can be derived from. We have, and we'll talk about 3D monitoring. We've got large sites, and even for construction purposes, here's a building that's being constructed that our client wanted to see edge of slabs and how they align with each other and stack up, so we can take 3D scans of multiple floors and combine them all together. Here's a video. And so this is a 3D aerial image of a forested areas. What is great we can actually remove all the trees and get to the raw land. And now we have an idea and can provide detailed topo of the actual land. So today we're really going to be talking about building and structure applications and land development applications. Let's start with building and structure applications. Again, I want to stress that the sky is really the limit for these type of applications. Interior and exterior spaces can be modeled more accurately than ever before. Accuracy is paramount to give our designers and end users a functional model that they can rely on and utilize data captured through the entire life cycle of the project. 3D scanning is great to map the existing conditions of details not typically able to be measured, architectural features, and design elements. Remember, traditional surveying tools such as it looks at a project point by point. What happens if that point was missed or not considered being needed when a team first goes out to acquire the information? I look at traditional surveying like we process it from point to point and then analyze the interpolation of the line work between the points. 3D scanning captures data over the entire wall, pipe, column, or mechanical structure. If the wall is not plumb outside where the traditional points are taken, 3D scanners will capture that. Because of the time acquisition and how fast it is, disrupting existing operations is at its minimum. Imagine for a second you have a historic building. A lot of the time the exterior facades matter and the end user wants to keep the exterior facades and update everything else. I say historic so any plans, as-built, or understanding of built conditions are based upon plans that you may or may not have, or they may be hand-drawn plans from the 1930s or 1920s. What happens? How do we take those design plans and apply them to real-world conditions that were never documented if there were any type of construction changes? The 3D scanner can capture what is, and all of those old plans can just continue to collect dust. So here is a case study. We were contracted several years ago to basically, we were asked to scan the interior structural elements, window locations, columns of a raised building where the existing facade was kept. And this was a 8-9-story building. And so all of the point positions were taken on the ground through 3D technologies. We then took this 3D scan and created a 2-dimensional plan and profile view that was then used for determining where future structural elements and the interior of the building was going to be designed and constructed. As-built measurements aren't always collected during active construction, or they are collected by a trade not to the same accuracy as you would want to or need for an as-built, but that's what you get. 3D scanning can revolutionize the collection of as-built data during construction or supplement what has been collected by the trade. Ultimately, knowing what was built will help alleviate construction errors, or at least give you the data needed to mitigate construction errors before a catastrophic event happened. So we worked again with a contractor at the Philip Merrill Environmental Center. Basically, it was a building constructed in the late 1990s, all made out of pressure-treated wood. During the construction, some of the support elements were not used, and some of the more architectural feature elements were, which made the building start to collapse. And so over the course of about a month, we scanned the entire exterior of the building, collected information on the support beams, anchor plates, and over 12,000 anchor bolts. The reason why we did this is that there was no as-built file to compare against the design to see what changed and why things were happening the way they were happening. So from the 120 gigs worth of data, we were able to create redline markups from the 3D data to provide to the design engineer to help save excuse me, around 6 months of development for remediation purposes. Hazardous areas and sites are also projects leveraging 3D scanners to capture data. Remember that the scanner captures more data than one point at a time. And so we do look at each project of where we'll set the scanner up to collect what's needed. I say this because, like I said before, in hazardous conditions, we may not be able to get right up against the structure that we need to survey. And so here is one, a CSX rail. It's an active rail corridor. Our goal was to figure out the bridge, find the location of the bridge, the rails, and do an analysis of a speed of a train traveling at a certain speed to see if that envelope that the train creates would impact that bridge. And so that's a great example of keeping our staff out of these hazardous conditions by sitting our instrument on multiple points. Same thing with crawl space or other confined space where, safety measures, safety equipment, and with crawl spaces and confined entry, there's a permit process. The scanner can be mounted and moved vertically, both into manholes, crawl spaces, up and down vertically. This is a static scanning, and utilizing the tripod, we can also move the scanner into ceilings, vents, and areas that require different vantage points than just the ground to be able to map and see details that we may not be able to see from those ground. So this is a government facility where we had to map the crawl space. We were not able to confine space because several years before, a sewer pipe busted in here, and this became a very hazardous area. So from one point vantage point, we were able to lower the 3D scanner to multiple elevations before hitting the ground, and we're able to map the entire the foundation walls, as well as all of the support beams and joists that made that crawl space up. And we created a Revit model for use by the design team. Same thing with utility as-built. Placing the scanner into the chamber will help prevent our field crews from having to go down there. It also maps that full structure and provide additional information that we may not have been able to collect by hand. The other place that we use it is building monitoring. We do a lot of work in DC and in other areas where, under construction conditions, we are required to observe existing buildings around the construction site. Most of the time, we're asked to provide optical monitoring at select points, but by using 3D scanning, we're able to monitor the entire wall. Here are a couple of different applications. This will be part of the presentation. I'm not really going to go through this, but these are different applications that the 3D scanner can be used as well. The other side of the coin, besides the building, let's switch to land development opportunities with the scanner. Exterior mapping can include many different tools to complete GPS, total station, 3D scanning, and aerial LiDAR scanning can all be incorporated together. We're not going to use total station and GPS on really large sites. We are going to try to leverage our scanning and LiDAR technologies from a higher altitude to capture large site conditions. We also use 3D scanning for site analysis. It's another big role that 3D scanners play. So we can look at security and the ability to understand the impacts of improvements around and may be affecting the site. So here's another example of an application in construction. This one involves acquiring observable earthwork data before, during, and after for quantity takeoffs and volume computations. I'm using a stockpile as an example, but there are many cases where 3D scanning can compare two different surfaces, providing a more realistic understanding of the changes of earth volumes on a site. This stockpile, see the bobcat in the center, it's very large, very steep, and not something that we would be able to survey on the ground, as well as that with the ever-changing amount of earth being moved, it was a very dynamic environment. So with the UAV, we're able to plan a path and take observations from the air with the scanner over a course of multiple days from the same spots to get very accurate information. Other land development applications, definitely take a look at it in the package to help visualize things that the 3D scanner can do. But we're going to pause for a second as we look to, we've got just a couple minutes left. We want to talk about things that the scanning pictures, the models, and deliverables aren't going to tell you. It's the accuracy. Not all scans are built the same, just as all scanners aren't built the same. So as an example, is looking at land development existing condition survey versus a county-wide LiDAR survey. In this example, the county-wide LiDAR survey was flown at 10,000 feet, and the purpose of the data was overall drainage studies and county GIS mapping. The accuracy of the type of LiDAR scan is plus or minus a foot. An existing condition survey using LiDAR survey is flown between 200 to 400 feet and is used for design of the site. The accuracy of this type of LiDAR scan is about plus or minus 0.2. The deliverables are both the same. Accuracy levels are different, the time of acquisition is different, and the end use is different. On the screen, you will see some examples of how modeling accuracy is defined, but you will never see it from the deliverable contours, line work, or even the dimensions. Knowing the expectation of the equipment and the end use is important to derive the models that will meet the purpose of the end user. So just a couple minutes left. I want you to put your hat on as a surveyor, and we're going to do some 3D scanning. And the purpose of this is, as mentioned, 3D scanning takes the field out of the field, but to do that, we have to deep dive ever so much in the sense that we are pressing a button to acquire some data, but the redundancy of the data and all of the variables that go into it, the first step to any scanning is going to be the workflow and planning. And so as we're looking to map out, we're looking and understanding that the scanner is line of sight. So we're figuring out all the different locations that the scanner is going to have to sit, or we're going to have to walk through in order to get the information. Depending on the site conditions, it may take multiple scan positions to map the entire object or project area. Defining that all up front is very important. Determine if the targets need to be tied to real-world coordinates. The scanner by itself will not tie to real-world coordinates. So in some cases, we will have to set targets. We will have to have known XYZ coordinates to be able to post-process. The next step is actually doing the acquisition of the data. And so as we're scanning from these different sessions, we are understanding the accuracy requirements, and we're providing the scanner as close to the object as we need to meet that accuracy. In the field, we can actually what's called register or tie all of the different point positions together, and in real time, we are stitching the scan together to see the results. Compared to about 8 to 10 years ago, where everything was collected on board and we didn't know if the information collected was done correctly, today surveyor is able to actually see a finished 3D model while they're producing the work. But all of the magic really happens when we get back into the office. We're doing the post-processing, the QC, cleaning up the scan for the uses. And one thing to take a look at is that most scanners scan a full 360 degrees. So it's collecting a lot of information. And so really when we look at the data sets, we need to trim up some of the information. And to do that, it's going to take a large computer, a very beefed up computer to process the information. And so We will then filter out any type of information and weed it down to the point where we are able to prepare deliverables just based upon the point cloud information that we need. And so some of the point cloud information is then converted to Revit. So in this case, we're preparing a deliverable for an architect where the top left is the actual scan. We're then converting it to a Revit file and then to a two-dimensional plan file. Another deliverable for MEP, we go out and scan the full MEP facility, create point clouds to a Revit model, to isolating just the machinery, and then ultimately at the end, we're creating a plan set. On the completely different side of the coin, a land development survey, we may not actually ever use or issue out the point cloud. Everything is derived into a two-dimensional drawing that meets the needs of the client and ultimately what the engineer will be looking for to use. With that, I appreciate the opportunity, and I'm going to turn it back over to you, Whitney.
Hey, well, Chris, that was very that was great, and I appreciate the detail. I know we only have a few minutes left, so if anybody has any questions, please feel free to put it into the chat. I do have a couple of questions for you, Chris, but why don't we dive in real quickly? So are there any type of projects that you would stay away from using a 3D scanner?
Most of the time, I would say no. The scanner, the technology, usually the laser bounces off and reflects off of the material. So really the only projects that we would stay away from is anything that has to do with water elements. So the scanner can't see through water and usually uses that as a void space. But most of the time, a scanner is a great application to use on most projects.
And to piggyback off of that, are there any misconceptions of what a scanner can and cannot do?
Yeah, that's a great question, Whitney. It can't see through walls, and I tried to make that as evident as possible. We have seen a lot of clients that want us to come out and scan into ceilings that don't have access points or underneath floors or through concrete. So the traditional 3D scanner is not going to be able to map those type of locations. It has to actually physically see and reflect off of the object that we're looking to map.
Okay. And how about one more, at least from my end, is from a time perspective and compared to the traditional survey techniques that you spoke of earlier, how much quicker is 3D scanning on projects when you could use either?
So I used the reference before of an interior space. And so to measure an interior space on a small scale could take 6 to 8 hours. We're now able to acquire information within 2 to 5 minutes per setup or walk through it. So reality is that we're really can do something in 3, 4, 5 times quicker than we traditionally have been able to in the past. And as the technology, like the mobile scanner, the backpack scanner, continues to evolve, it's going to become even quicker. Now, on the opposite side of the coin is going to be the processing of the data. We're bringing in terabytes worth of data, gigs worth of data. And so to be able to process that, to be able to weed out what you need is really where that time consideration is going to come from. So where you're saving 3 to 5 times in the field, you're probably adding 2 times worth of office modeling and processing to get what you need. So it does balance out, but definitely 3D scanning has disrupted our industry to make acquiring data a whole lot easier, and a lot more information is able to be used today.
Okay. No, that's great. If there's any questions from the audience, feel free to add. If not, Chris can definitely stay on for a few extra minutes. Let's see. Oh, go Monarchs. Well, that's the ODU. Yeah, okay, that's right. But if there's any other questions, feel free. If not, but no, definitely really appreciate the your time with us here today. It's very, very, very informative. Um, and I think there's definitely some interest. But before we wrap up our program here today, I would like to share some of the upcoming events that we do have planned. So please mark your calendar for some of our upcoming local host events, as well as some of the upcoming national events. So we are committed to bringing you all some more content and fun events through the rest of the year. So our next First Friday session is on Friday, October 6th. It's a popular request from our members is common contractor mistakes in asserting and defending bid protests from Maria Pancinelli from McCarter in English, and all participants will earn one PDH certificate, and registration is open now. And are you interested in sharing your knowledge on current educational topics as part of our First Friday series with our members? We are accepting presentation applications starting next year. So please go to our website if you'd like to submit a topic today. Our Team River Runner Family Day Kayak and Picnic on the Potomac is set for Sunday, September 17th. So enjoy a day with your family on this free event that's sponsored by AFG and hosted by the DC and Mid-Maryland Posts, as well as the DBIA Mid-Atlantic. We only have a few spots left, so don't wait to register today. You can join us for the DC Post Annual Scholarship Golf Tournament on Wednesday, October 4th at the courses at Andrews. You don't want to miss out on a fun day at one of the most challenging courses on the military installation at Joint Base Andrews. So this fundraiser event supports our scholarship and STEM educational events sponsored by the DC Post. So you can go to the website and sign up to show your support today. And then one of our most popular social events of the year is now open for registration, our new fiscal year networking social at the Capo DC Speakeasy. Join our special VIP guests from Space Force Command, SAME National, and DC Post sponsors, as well as the board of directors, as we gather to connect, communicate, and collaborate with the start of the new fiscal year. It's a fun event, prize giveaways, so it's definitely something you don't want to miss. And then the save the date for the 2023 joint conference with CMMA National Capital Chapter. This annual event brings together several government agencies to help you understand trends, opportunities, and strategies for the new fiscal year. Join us at the Army Navy Club at Farragut Square for the annual fall joint conference. This can be Thursday, October 19th. And then, so you don't want to miss these events. And so please feel free to visit our website and mark your calendar for these upcoming events, as well as national events. So thank you all again for attending our First Friday with Chris Fillmore from IMEG with excellent content today. So please be on the lookout for document delivery in the email subject line, your PDH certificate for the registered participants, and we'll post a recording on our website later on this month. So have a great holiday weekend, everyone, and we look forward to seeing you at our next event. So thanks again. Chris, great job. So Chris, I have a curious question on my end. So
Sure.
what type of analysts are you hiring on your end to really do a lot of the processing of data? Or are you actually having like AI bots kind of like break down the data?
No, I mean, most of the time it's going to be, I would say, Revit modelers, Excel good and being able to manipulate this data. It's really dumb data. It's just really XYZ coordinates with, it also measures the intensity level or the energy return. So we can basically determine what type of material it is. So asphalt returns at a certain energy, concrete returns at a certain energy. So being able to go in, manipulate the data, and then within the program itself, there's AI and other scripts that then can weed out the data, slice the data, that is then used and basically incorporated into Revit modeling. So then from there, that data then can be used for anything. So that can be pushed over to our engineering analysis for looking at site lighting and really security systems and seeing where lighting is needed. It can be brought over to our civil engineers, contours, relief of land, looking at drainage divides, things like that. So a lot of end uses for it, but to actually bring the data in from the scanner and bring it in, it's really manipulating those geodetic type coordinates. So hope that answered it.
No, it definitely does. I'm just curious, like how you're actually, how you're manipulating the data, and if it's actually you're having to hire FTEs to do that. If that's now the cost of where you're kind of moving a lot of I got to hire actual data analysts,
Right.
or that's where the money's going, or how you're looking at bringing in AI experts or data scientists to kind of manipulate that data for you.
Right. Yeah. So, I mean, a lot of the civil applications, we will actually look at our land surveyors to do it because as the data is being taken from the scanner into the office, we don't necessarily need all of that data for what we do. So we actually are modeling snippets or weeding out a lot of that data. And so a surveyor is going to be able to know how is the computer going to interpolate and create a tin surface or a DTM surface for elevations and relief of land. So on the other side of the coin, we have architectural modeling, and so we'll use more of a Revit model architectural type team member that will know how to derive the data, go through and isolate the data that they need for that application. Same thing with our security systems and light analysis is we'll derive the data and give it to their team members, and then they'll do their analysis from that data set. So
Okay, got it. We did have one last question. Do you need a fixed point, elevation and horizontal reference to accurately use this tool?
not always. It depends on the application. So if we're just going to go into, let's say, a office space, and really the end goal is to measure the walls, we won't necessarily need to have control points with real world XYZ coordinates because most scanners now do what's called automatic tie points. So it actually has AI built into the unit itself, and as we're walking along, it's classifying different edges and architectural features that it sees through its 8, 9 cameras, and it's tracking it as the scanner's moving from one spot to the other. If we're looking at it from a land development standpoint or relating multiple floors together where we're turning off the instrument, going up to the next floor, that's where we're going to have real world coordinates, is to expand the 3D model outside of one environment and put it into multiple environments.
Okay, great. Well, I appreciate that breakdown. I don't think we have any other questions, and so I think we'll close it out now. So thank you everyone for joining, and have a great Labor Day weekend. And we will all see you at the next DC Post event. Great.
Thank you.
All right. Thanks. You're welcome.